For this problem, the Venn diagram will look something like this, where you have A here and B here. You have A here and B here, and this will be C. So if you have C being a subset of A and not B, which will be this crescent moon looking area here, C is the subset of that. That will imply that the intersection of B and C is the null set. That is, this circle and this circle do not intersect at all. I'm going to skip a lot of the little things, such as writing out X is an element of A and that, and I'm just going to keep everything in capital letters and just go through it real quick. Okay, so we'll rewrite this. C is a subset of A and not B implies B and C is a subset of phi. Remember, this equal thing is two things. It's both phi is a subset of B and C, and B and C is a subset of phi. Phi is a subset of all sets, so that first statement, phi is a subset of B and C. This is a trivial statement. We don't need to prove it. So we want to stick with the arrangement we have here. Okay, and we can rewrite these belongs to as or statements, not or statements as implies. And again, you're supposed to write this as X is an element of A and not B, and you would write that for everything, and then you would rewrite these with lowercase letters to indicate that you're using an element inside of B. That's what you're working with. And you know what, I'll write them as lowercase letters from now on. But I did skip that one step that X belongs to, just for your information. So here we have C, so not C, or. Remember, we're using the not or equivalence. A and not B. Wrap this up. Use the same not or equivalence here. Or B and C. And then the not or equivalence. Or phi. I'm going to use, first distribute this using De Morgan's law, taking care to keep this thing wrapped up in parentheses. That makes a big difference. C, the sign switches because of De Morgan's law, and we're going to need to use De Morgan's law one more time. We're going to use De Morgan's right here. Not B or not C. All right, one more step and then we should be done. C and not A. De Morgan's or B. And then this statement here is the exact same. Not B or not C or the null set. So this was our final statement. This comes from this. And we're going to look at it in a truth table now. And it looks like this. These are the same things, yeah. Not A or B. Okay. So this is the truth table here, and it's a little bit off screen, so let me move it. And so this is the final truth table we're looking at. I put C up here front because there's a C term here, and we can just go ahead and denote all of these in this first one as false. And so we have two terms. We wrote this as one term. Since there's an or statement here, that's called a disjunction. So we were able to have a column for this one and a column for this one. And then finally, we can say A or B. And if either this is true or this is true, then we're fine. We have a good tautology. So just notice that this is a disjunction. So if C is false here, because this first part we have an and statement, so all of the C's are false. And I drew C as the first column, just because you have 4 in a row, and it just makes it slightly easier. So C is true in these first 4 rows, not A or B. Okay, we have B is true here, so that works. And then B is false here, and we do not have a not A. Here we do have a not A. We have a not A here. And so that's what it looks like for the first column. For this part of the disjunction, not B or not C or an empty set. So that does not work for any of these. Here we have a not B. So that works. Here we have a B is true. It doesn't matter. We're looking at, so both not B and not C, those are both false. This is false. For this guy, we're looking for a not B or a not C. We have a not B here. So this is true. And for the last 4 rows here, we have a bunch of not C's. Not C, not C, not C, and then another one. So that means this right-hand part of the disjunction is true for all 4 final rows. This or phi, that just means in empty set everything's false, so that would just be this last one. But yeah, that's true anyway. So if we have A or B, where this is A and this is B, we have true, true, this is true, true, last 4 are true, so everything is true. We have a tautology. So that is how you do that guy.